Grazie, buonasera. Firstly, thank you very much for the invitation for this event. Thank you to Marco Bieri and the organization of this event. We are working in precision farming, working in a different international project. Here there is two examples of this kind of project. At the beginning, I would like to show this picture. Now, currently, we have a different kind of sensor, UAV, global navigation satellite system, LiDAR sensor. If we put all of this technology in the field, we can do variable irrigation, yield monitoring, variable rate application, with control and precision seeding. This is the present of the agricultural production. Some of our motivation to work in precision farming, I put here some of them. It's a new strategic tool and technology for sustainable weed management. An important operation for farmers is weed control. So we have a new tools to help to the farmer. Agricultural automation to maximize the production of the hectare. Variable rate application. Not only herbicide, also thinking in water, put just the water that the field need in each side, and also agricultural vehicle robot. This is the future. Another technological motivation for us is RTK GNS technologies are increasingly used by commercial farming operation, but right now it's using only for guidance tractor. But in the future, this location, this position, will be using in different operations. Many countries, companies are creating network of base stations, so this reduces the price of the location system for the farmer, so this is a good thing. And also the price of sensor instrumentation, a guidance system are decreasing, so this is also a good thing for farmers. Some unsustainable aspect in agricultural today is something like that. This means 7 people working in the field for weed control. This is unsustainable system for this kind of crop. This crop is stevia, so it's impossible to keep the production of this crop with this system. Normally, the price of remove the weed with people is 5 times bigger than using herbicide. This is another example of unsustainable aspect. 2 people to do only one operation in the field. It's the people back in the implement. It's moving the implement to not remove the sugar beet when it's doing the cultivator. Here to picture about the weed control manual with 2 people. This is in California, and the other one is in Sevilla, Spain. It's the same concept. It's 5 times more expensive than apply any kind of herbicide. And the question is this picture precision farming? Some research say precision farming is applied the right treatment in the right place and the right time. But also for me, for the people that are working in precision farming, is using the new tools to do this, okay? Let me show you 2 different projects that right now was completed. One of them is plant mapping and night-based weeding system, and the second project is intelligent sprayer boom. You have here some address to know more about this. The first one project is a project in USA. We were working there the last 5 years, and the objective was mapping where the tomato plant is with very high precision. And the second objective was weeding, using an actuator to avoiding the tomato plant and remove all the weed automatically. For mapping, we're using the RTK GPS receiver mounting on the transplanter and the implement. Just when the transplanter was putting the tomato plant on the field, the location of this tomato plant was recording, and after we created the map of this tomato plant are in the field. Using one system like that one, the tractor, and in this case we're using two GPS receiver, one mounting in the transplanter and the other one mounting in the tractor to get two maps. The first map was using the RTK GPS mounting on the transplanter, so we know it all the coordinates of the tomato plant with the error about 2 centimeters. And the second option was using the auto guidance system of the tractor to know where the plant is and compare the both. This is a part of the methodology that we're using for this project. You can see it in the top of the transplanter, the RTK GPS receiver, the tilt sensor to correct the pitch and roll. And also when we use the GPS of the auto guidance system mounting on the tractor, we have to correct also the gap. It's the deviation between the tractor and the implement. Here you can see all the electronic system that permit you using or recording the map that we were creating. Here was the automatically system to estimate where the plant is. And in the picture in your left, you have the manual GPS location to compare with the estimate plant location. Just in the center, you can see the tomato plant, the tomato map that we were creating. We're using different track, curve and straight with in the field experiment, just to test that everything was working good. And some results of this project was, you can see here at the end, the mean and the standard deviation was 2.4, 2.9 centimeter, the mean, and 1.2, 1.7 centimeter of error of a standard deviation. This means compare the real location of the plant with the estimate location of the plant with the transplanter. Here is how we were working in the field. You can see it in the top of the transplanter, the GPS antenna. There is the wheel, transplanter wheel, all tomato plant we put in there, and when the tomato plant is dropping the soil, just in this moment, the GPS takes the location of the tomato plant. So we have a tomato plant there, an absolute encoder, so we know exactly the position where the tomato plant was dropped. You can see in the bottom of the movie when the tomato plant dropped in the soil. And after that, we have this kind of map. This map is very important because this map is an extra operation. It's a prescription map after to do any operation in the field. This means we know where is each tomato plant, so in the place where there isn't any kind of tomato plant, we can remove everything with herbicide, of mechanical system, of another kind of system. So this is the prescription map for the next step. The next step was knife-based weeding system. It's something like that. You can see it in the big plant. The green one is the tomato plant. So if you know here the location of big tomato plant, so you can actuate like one knife, open and close, avoiding the tomato plant and removing all the width between tomato and tomato plant. Of course, you have to provide safety area here for no damage the roof of tomato. The prototype of implement was something like that. It's a knife within intra-row crop and conventional cultivator within an inter-row crop. Was something like that. You know, the knife was open and closed, avoiding tomato, and removing all the plant between these two plants. So we don't use herbicide here, just mechanical system to remove the weed. Let me show something about the project 2. The project 2 is a European project. Marco mentioned it before about the RIA project. It's a fleet of robots working in the field for farmer. In this, our task in this project was creating an intelligent sprayer only to put herbicide where the weeds are. The main idea was a fleet of robots, autonomous tractor like that, working with the field sprayer, apply herbicide only in the places where we have weeds. But we need the prescription map. So the prescription map we're taking with drone, fly the field and taking the places where the weeds are. So normally in the field, you don't have weed in all the field. So you can fly with the drone with the appropriate camera and take the places where the weeds are. After that, you have a map like that for apply herbicide, just in the place, in the green place. For that one, we developed the intelligent sprayer. This is a schedule of the hydraulic system. There is two main components. There is a direct injection system. The water is another. So we have separated the herbicide and the water and put just in the moment that is necessary. Each nozzle of this sprayer was working independently. So the width of our operation is not like 6 meters, 8 meters, or 12 meters. So each 1 meter, the width of the nozzle. This was a prototype. This is a prototype was created for the autonomous tractor. This system read the prescription map and apply herbicide only where the weeds are. So each nozzle here, you can see in the bottom, are working independently. It's open and closed when are weeds. This is a picture about the development of the implement in Zedenhel in Belgium during the RIA project. And that's it. It's working like that. The autonomous tractor with the implement behind the autonomous tractor. Here you can see it after the orange stick is the weed patch is there, and just open the nozzle that has to apply. The field bar has 12 nozzles and just opening 5 because the weed was concentrated in this area. So this is sustainable herbicide application. Just some conclusion of these two projects. An example, there are many other projects, but for this event, I bring this one. So some conclusion is mechanical actuated intra-row with knife can achieve significant reduction in both manual labor and apply herbicide while maintaining weed control efficacy. This is one of conclusion of the first project. The second project, the sprayer broom prototype, could be used in precision agriculture to implement site-specific management technique for variable rate application of cereal production input using a math-based prescription. There are only two conclusions here, but just I put this technique, this technology, you can test, you can try to put in vinegar or another kind of crop. The precision farming in many cases is technology, tools, instrumentation, sensor, and after you have to apply on a different crop. So, gracias.
Thank you, Manuel. Please stay here a moment. C'è qualche domanda? Do you have any questions for Manuel? Any comments? Marco, vuoi fare qualche commento?
Manuel, we are talking about wine. Tomato in this stage is like wine. What do you argue about application in vineyard, or we worked about olive tree is in the same application?
You mean the application of weed control application or
with control or variable rate treatment?
Yeah, it's the variable rate application. I show you the field sprayer, but something similar could be created for orchard or vineyards, just to put herbicide in the, depend of the volume of the tree that you have in your field. You can monitor the volume of your tree or your vineyard, and after do application according with this monitorization.